Hello, everyone. So for this session, we will be discussing about some similarity metrics. So the first is we use this utility matrix for the following example. So we have 4 users here and 7 items. And here are just some arbitrary values. Okay. By visually inspecting this table, the recommender system that we will be creating should capture the intuition that the similarity of the user 1 and user 2 should be greater than the similarity of user 1 and user 3. Because the values for U1 and U2 are more or less high, but the value or the rating for U1 I5 is 1, but when you look at U3, it's 4. It's basically the opposite. That's what we're seeing here. High for U1, it's low for U3. That's the in here. So the first metric that we will be using is Jaccard similarity. And in Jaccard similarity, we are simply checking the intersection over union of the rated items. This is akin to treating the values as implicit ratings. So we'll be using the same utility matrix here. And basically, we treat them as Booleans, just Boolean values. So 1, 0, 0, 1, 1, 0, 0. Again, we're just getting the intersection over union. So the Jaccard similarity for U1 will be 1, of course, because you're computing the similarity of that vector against itself, so it will be 1. But for U1 and U2, it will be 1 over 5. Because if you look here, the only intersection is this one, the 1, 1, and the rest are not. We're just looking at the cells where there's a value. So there are only 5 cells that have values. Okay, so for U1, U3, it will be 1/2. And for U1, U4, it will be 0 because there's no intersection. Now, what are some limitations of Jaccard similarity? So we were expecting that the similarity of U1 and U2 will be greater than similarity of U1 and U3, but we got the opposite of that. Apparently, the similarity of U1 and U3 is better than U1 and U2. So that's the limitation of using Jaccard similarity because we're treating the values as just Booleans. Another metric that we could use is cosine similarity. So in cosine similarity, we are looking at the angle of the 2 vectors and not their magnitudes. So there's a formula for cosine similarity. It's we'll be using Rx and R sub y here. So R sub x is vector of ratings of user x, R sub y is vector of ratings of user y, and R sub x times R sub y over the magnitude of R sub x. R sub y is your cosine similarity. So if we use that for the given utility matrix, we will end up with the following similarity scores. Again, similarity of U1 and U1 is just 1, but for U1 and U2, it will be 0.38. For U1, U3, it's 0.32, and U1, U4 is 0. And based on that, we will be recommending, of course, U1 and U2. And this is now what we were expecting based on the intuition that we have earlier that U1, U2 should be greater than U1, U3. Sorry, take a step. Yeah. Okay. So another variation of this is the mean-centered cosine similarity. So basically, we're just applying mean centering to all of the values here. So basically, we're taking into account the user's rating behaviors. So we start with the original utility matrix. We get the mean of the vector and apply subtraction. And now we will end up with these values. So for the blank ones, it's just 0, And now if we compute the cosine similarity of those, we will end up with the following. So it will be 1.09 and negative 0.55, and finally 0. Okay. So we still got what we were expecting. Similarity of U1 and U2 is better than similarity of U1 and U3. But finally, we have Pearson correlation. So this is the formula for that. If we impute the missing values with the mean of the user, we will get the same results as the mean-centered cosine similarity. So Pearson correlation is basically the earlier variation that we had. So this is the cosine similarity mean-centered. That's basically Pearson correlation. You will end up with the same values. So the summary of those similarity metrics. Jaccard, for Jaccard, we ignore the rating. So this is basically implicit rating for your commander systems. For cosine, we're looking at the angles of two vectors and not their magnitudes. We treat the missing ratings as negative. That's what happens if we do cosine similarity. For Pearson, this is basically cosine similarity with mean centering. It considers the user's tendency to rate high or low. The missing ratings are treated as average ratings. That's it.